Fine. So yesterday I think first we had some practice for creating an exception class. Fine. And then using it in various methods using the throw statement. Throw and throws. Fine. And then yesterday we talked about handling exceptions using try and catch and also the finally block. Fine. So you may be able to use try, catch and finally. Fine. A catch block is nothing but the exception handling part. Okay. Catch block will always have one parameter, and where you specify the types of exceptions that you would like to handle. Fine. Okay. And that you would like to handle in the corresponding try block. Okay. Fine. So another thing about this try catch block thing is try catch and finally. See, where can I use try catch? Anywhere. Fine. Wherever you have statements inside it would be inside methods, constructors, or even a static block where you write statements for execution, right? So at any place you can use. Fine. You have a set of statements, and it's possible that any statement can always have an error. Fine. Checked, unchecked, whatever. Fine. Any kind of error may be possible. So if you feel like, okay, in this case here I would like to handle some exceptions, okay, you can have a try catch or even try finally, because you would like to release some resources. Fine. We also have another form for some of those kind of resources which are auto closable. Okay, most of the resources will be auto closable, in which case you can use try with resources. Okay, fine. This thing you would be able to use when we look at the Java IO. We do some input output. Fine. There we may be able to open file and we would like them to be closed. Fine. Open a file for reading or any such resources, or maybe for even when you use JDBC, that is your connection with the database, and you want to execute some SQL queries. Okay, you need a connection. So connection is a resource. From connection various other resources are also created. So for all of those, yes, creating those resources would be in a try with resources. Okay, so try with resources, and you use those resources in a block. There's no need of a finally. And you may, if you want, you can put a catch block, but no need of a finally. The close in finally, what we would like to do is close those resources, release those resources, right? So close would automatically be called on those objects which are created inside the try with resources. Fine. So this example we may do at a later stage. Fine. Okay. So other point was, yes, we can use this try catch finally or try catch, fine, or try finally. Three forms are there, right? You can have try and catch, try and finally, or try catch finally, all three of them. Fine. So these things can be used wherever we write statements, which would mean inside a catch block you have got statements. You can again have them in a try catch finally. Inside a finally block, you have got statements. You can have its own separate within a finally block. You may again be introducing a try catch finally kind of a thing, or even within try you can do nesting. That's it. Within try again a try catch finally, whatever. So anywhere you have statements, so any kind of nesting. But yes, for a try there should be its corresponding catch and a finally, catch, a finally, whatever. And every try will have its own catch and finally block. Fine. Okay. So Fine. So let's look at this try catch finally once again. Okay. Let's just look at various scenarios. Okay. Fine. Just to understand the flow of control. Fine. How the flow of control will be there. So for this example, let's consider something like this. We got some kind of a method M1. Okay. Inside the method M1, there is some statement, let's say S1, fine, which in turn invokes a method M2, and there is some statement S2. Fine. So that's what method M1 is. Okay. Now for M2, let's see the method M2. M2 may look something like this. Okay. M2 may have a return type. Fine, we'll introduce return type later. So let's assume initially return type is void. We have the method M2, okay, which has statement S3, S4, then a try block for statements S5, S6, S7. Okay. There is a catch block for some kind of exception E1, okay, and it has got statement S8, S9. Another catch block for a different exception, that is E2, okay, and we got S10, S11. Fine, let's also keep a finally block here. So we got a finally block which has statement S12, S13, fine, and then we got some statement, fine, some additional statement here, S14 and S15 maybe. So these are the, fine, that's how the things are. We have M1 invoking a method M2, which is something like this. Fine. Now, what statements would be executed? Fine. If there are no errors occurring anywhere and someone invokes method M1. So someone is invoking M1. Fine. What sequence? Fine. And what statements get executed here? So normal, no exception occurring any place. S1, yeah, yeah, S1, it invokes M2, so S3, S4, S5, S6, S7, after S7, S12, S13, S14, S15, it completes successfully, no errors, and therefore S2 and out. Okay, fine. What statements would be executed in case we have exception E1 occurring in S4? Yeah, S1, S3, S4 is error. So S4 has failed. After S3 what? Failure then? Fine. Huh. Fine. So it comes out with error. M2 has failed, even S2 is not executed. Okay, fine. We have no handling here. There is no handling of E1 occurring in M1. Okay, fine. So what statements would be executed in case fine, we got error E1 occurring in S6. So S1, S3, S4, S5, S8, S9, S12, S13, fine, S14, S15, method is completed successfully, it would execute S2 also. Okay, fine. This finishes the method successfully. E1 which happened at S6 has been handled. Okay, so it doesn't come out with error, it comes out successfully. Okay, fine. Okay. Yeah, so what is the flow in case we have error E3, some other error, not E1, not E2, but some error E3 occurring in S6, S1, S3, S4, S5, then that's an error. So where does it go? Okay, it executes after S5, then it is next statement is S12, S13, then fine, then exception, fine, doesn't execute further. Okay, finally is not a handling part. Fine, finally is because it has to go out, but still it has to do this, finish this job, and then it was throwing, right? This was not handled, E3 is not handled, so it's not handled. Here it is coming out with exception, E3, it has M2 has failed, S2 is not executed, and S2 won't be executed. Fine. Okay. Yeah. Another thing is, we have the same thing, right? Okay. So we have this error, or let's take a different thing. We have error E1 occurring in S6. Okay. And we had seen this earlier. So when E1 was occurring in S6, after S5, it went to S8, right? S9. Now let's assume what happens while executing S8, S9 is, at S9, it throws error E2. S9 fails with E2. So what happens? E2 is raised at S9.
S8 के बाद S12, S13 S10 और S11 भी होगा.
1, 3, 4, 5, then S8, and then finally S12, S13. S12, S13, and what is the exception here? E2. This has come out with E2. Throwing exception E2, S2 not executed. Fine? Okay. Fine. This was handled basically. E1 got handled. See, this E2 is at S9. The catch block here is for these statements in the try here. It's not for anything else. Okay, it's for the try block here. Fine. If this were to be handled, you put a try catch for this then. Again, you can always have a try catch. If you want to handle E2 occurring in S9, have a try catch there. Fine. Try catch can be put inside any place. In a catch block, or you want to have a try catch, that's possible. Yeah.
Then S7 will not be executed.
No. Fine, S7 is never executed. Fine, it has come out. Fine, it was to be thrown, but there is a catch block. Okay, so executes the catch block. And enters the catch block. S8 gets executed. S9 again fails. Now in this case we are saying S9 fails. But yes, you are moving out. You have done this try. You are moving out. You need to finish the finally, then go out. It was throwing exception E2. Fine. E2 because of S9. Fine.
So what if
Yeah.
Exceptions E2 also occurs at S7.
Exception E2 occurs at,
S7.
but S7 it never reaches. Because after S6, it's not proceeding further here. It has. Fine. Okay. Now case here is something like this. Which one? You are talking about suppressed, right? Let's see the suppressed thing. Okay. Yeah. What you might have is maybe we have something like this. We have error E3 occurring in S6. We understand it will enter the finally block, and in the finally block in S13 there is error E4. The exception is E4, right? We understand, right? After S5 it had to throw, but before throwing out it had to do so finally, right? So while executing the finally, it encounters an error E4 in finally. So yeah, it is after S12 it's throwing. What's thrown here? Is it E3 or E4? It was throwing E3, but then the finally said, okay, we need to throw E4. So what will be thrown? E3 or E4? फाइनली में क्या था लास्ट में? E4. It throws E4. What is being thrown is E4, but in E4 there is this suppressed exception called E3 available in E4. Okay, fine. We have the exception E3 as a suppressed exception for E4. Fine, you have that method called get suppressed. It returns an array of throwable. There is one more method in throwable called get suppressed. So this is a scenario where the exception is exception gets suppressed. Okay, another case. This is clear? Okay, so another case we'll have is slightly different now. Now this is something with finally, right? Things happening at finally. So in finally, no, it's not an error which is happening. Oh, we had error E3 at S6, but then while executing the finally block, maybe in the finally block instead of S13 we have something like this. We have some kind of a if condition. If there is some condition, then it wants to do a return. In the finally block, someone has written like this. Oh, if this is what the scenario is, okay, so there is some condition. So there is with condition, it says, okay, I'll return. Maybe there was a return type instead of void. Let's make it as return type of int. In which case, this was saying, I want to return a value of 1. Okay. There must have been a return statement at the end here also. So there is a return statement here for returning a value of 0. It has finished successfully and I return a 0 maybe. Fine, we must have a return if there is a return type. Okay, so now let's see what happens. S1, S3, S4, S5, exception E3 occurring in S6, fine, enters the finally block, S12, and then we have this if condition and it says return 1. Yeah, so what happens?
Condition is true, then return 1.
Condition is true. Let's assume that condition is true.
Then return 1.
Fine. So how does the method finish? Successfully or with failure? Fine. The method is finishing with a return. Okay. So M2 will get the value of, what will be the value received? 1. Fine. M2 finishes with the value of 1. Okay. Okay. Another thing. And let's have. Oops, sorry, I must remove E. Okay, we don't have exception here, but we have maybe in the sorry. Yeah, this is exception E1. Okay. We have exception E1 here. Okay, let's keep exception E1. But then in the catch block, it says instead of S11, it was saying let's return 2. This was saying return 2.
So लेकिन वो कैच में तो जाएगा नहीं अगर एक्सेप्शन
E1 है. Oh sorry, E2 में डाल दिया मैंने. So okay, so let's make it E2 then. Let's make this E2. Yeah. So S1, S3, S4, S5, there is an exception E2 in S6. Okay, enters the catch block for E2. S10, S11 is a return maybe. It says return 2, so it has to return 2.
finally वो
But it before returning, it has to go through
finally.
finally.
So it's also
It will enter finally block, says S12, and then it says okay, let's assume the condition is true here.
also return
So this one says return 1. So what is returned? 2 or 1?
1.
Fine, it will be returning 1. Fine, it will return whatever happens in finally. Fine, fine. See, if there is execution of finally, finally can change the state. It was an error condition and it could become a, so maybe if it was E3 still, the earlier case was this was E3, but this was saying return, finally says return. Okay, there's no error, I can return a value. Fine. It was another case could be maybe that in the try block itself there could have been a return statement. Fine. While returning, it has to execute the finally block. Finally can have a different return. Then that finally return will be happening. Or in finally it could be a failure. Then the failure happens. Okay. This was saying I can return a value. But before it can return the value, it has to go through finally. And while executing finally, things can change. It can become an error. Return is successful, right? But it can become an error because finally had also to be done before I return. Clear? So anything happening in finally is the last thing. Fine. Error condition was there, or that can become successful because finally can return a value. Fine. Or it could be other way around, or there was an error condition which was not even handled, E3 was there, but finally says okay, I can return a value. Fine, if you can return a value, that's it. It's coming out with the value. Fine, clear? The flow of control, try catch finally. Fine. Okay. Fine, so this was about the flow of control. And now I think so now it should be possible for you to handle your negative mount exception at places where you want. Main need not have a throws now. Fine, main need not have a throws, but your your deposit, withdraw, and the constructor, they should have a throws. Yeah, fine, they should have throws, right? If someone does a deposit with a negative value, I am going to throw. Fine, don't look at what is the code I am going to write, that comes later, but I have decided that yeah, I have a parameter here. Okay, another thing was our exercise was more about understanding exceptions, right? How to write our own custom exception. But many places you can use ready-made exceptions also. There are lot many exception classes which are in the API, in the library. Okay, fine, there are a lot of them. So if for example in case of what was the problem with our negative value? Fine. The problem is about argument being invalid. Fine. So we do have some exceptions. Let's check. Fine. Let's check the exception classes. Some of the things from the API. Because there is something which is more appropriate. If you don't want to create our own exception class, you could use some ready-made classes. But in this case, that class here is a unchecked exception. But it could be used at many places. It's just in java.lang, let's check java.lang package. We have these exceptions, and there is this illegal argument exception. You can see that. Yeah. That's for where the argument is illegal. Throws to indicate that a method has been passed an illegal or inappropriate argument. Fine. Isn't that more appropriate? Right? So maybe we need not have actually created the negative mount exception class, and we could have thrown this straight away. Okay, but understand this is you can see the class hierarchy. This is under the runtime exception, it's an unchecked one. Okay, so if you want to have it checked, then going for your own exception class is a better choice. Fine, but fine. See, with checked, you are bringing to the attention of the user of this class or the user of this method that there is a possibility of this error. Fine. Have you done the checking, or have you handled it, or you mention in your throws? Fine. This even has some other subclasses, so many other subclasses. So you could have even done your illegal argument exception subclass and said illegal amount exception. Fine. As a subclass of illegal argument exception. There are so many of them, see. number format exception is under this. Find number format exception. Where do we find this? The parseInt method, integer.parseInt method, and that was number format exception. Fine. So you have lot of, at least in this java.lang package, you should know some of these. So this is one illegal argument exception which you may have been using. Illegal state exception. Okay. Fine. You have some class whose object is having some state, and in that state some methods are not allowed. In a particular state a method is not allowed. Then you will say illegal state exception. It can throw that exception, illegal state exception. And for example, the account may have a field, a boolean, to say whether it is currently frozen. Fine, account has been frozen. Account is in a frozen state, in which case a deposit or a withdrawal should not be allowed. Fine, so you could do a check. If that boolean variable is frozen, is true, fine, you can throw illegal state exception. You can't do this activity. Fine. You may only call the display method to see what's there, but you can't do a deposit or a withdrawal. Fine. So it depends on your class, your requirements. Fine. So like this, there are some good exception classes here. Okay. Many of those are used, index out of bounds exception anyway. Many of those are fine. Unchecked exceptions occurring in lot of places. Index out of bounds is one, and it has a subclass called array index out of bounds. That's a subclass of index out of bounds. Array index out of bounds, right? And subclass of index out of bounds. Okay. We had the arithmetic. Yeah, that's a arithmetic. Check. Fine. Runtime exception. And number format exception was the other. And that's the other one. You can see it's a subclass of illegal argument exception under the runtime exception. So these are the unchecked ones. Fine. Those three statements, recollect, a equals integer.parseInt. There were three possible exceptions. Okay. Okay. And there are those errors. And we have one of those which I had mentioned was out of memory error. Fine. They are subclasses of error. Okay, they are subclasses of error. And one of the errors here is this one. Okay, now this error is related to a statement which I'll talk about now. Fine. Thrown to indicate that an assertion has failed. Many places they'll talk about the language specifications. and it's quite very technical, that Java language specification, if you try to read, but it has all these, see, all those constructors would be there. Message. So any type may be there. So they take care of all types basically. Okay, fine. Let's look at this. Okay. Fine. So clear about the keywords what we have seen. Started with the keyword, comparison of return and throw. Fine. So you understand throw, and to fail something, opposite of the return. We understood throws, it's a declaration. Fine. Method and constructor, they can have this declaration. Fine. It becomes compulsory for checked exceptions. Throw, throws. Then we looked at try. The other keyword is catch. Another keyword is finally. Fine. So these 5 keywords are fine. Okay. Okay. Now we have another keyword. It's again a statement called assert. And we got a statement called assert. Okay, fine. I am measuring distance between 2 points. Fine. So maybe I have written a method to measure the distance between 2 points, and so someplace I'll call the method, I'll say int or whatever, maybe it's int d equals, call the method to get the distance between the 2 points, maybe something like this was done. Fine. And then I might write a code which says assert d is greater than or equal to 0. Has to be. Fine. Your method for measuring the distance can't be returning a value which is negative. Can it be negative? It can't be, right? It can never be negative. Okay, so I can always write some assertions like this in my code. Or, as someone who does testing, fine, he might even do the job of saying assert d equals, and he knows what the distance should have been. Okay, what the distance should have been, and puts that value here. Okay, distance between 2 points which are same, he passes the same value for, and he says this should be 0. And these are nothing but some statements which are supposed to be true. If that's not true, there's something seriously wrong. Fine. You write test cases for your methods. And you write test cases for your method. For example, okay, whenever I do a deposit, okay, I might say long initial balance is equal to AC dot get balance okay. Then I'll say okay, I have a variable amount AMT. I'll say AC dot deposit something called amount. Amount is another variable for which some value is available. And then here I might write assert okay, AC dot get balance should be equal to initial balance plus the amount. Assert and a Boolean expression, that's it. Assert followed by a Boolean expression. Things which are supposed to be true. Normally we would do some, we have test cases for our methods, and for those things we might be writing some assertions. And they are supposed to be true. If that's not true, this class is not supposed to be used. Someone has modified, made some changes, but then because of that change, if this is not happening, fine, while fixing a bug, you introduce another bug. You made some change somewhere and that has affected some test case. You can see assert, I'm writing a test case. And I'm just trying to ascertain that this is still maintained or not. Fine. So you can put assert statements. Fine. You can have assert statements. Okay. Fine. But don't think too much about assert. In the sense, assert are not executed. You put these statements, they won't be executed unless you ask that, yes, run my JVM with assertions enabled. By default, they are not there. Fine. So in production, I don't run with assertions. During the development, for my testing purpose, I will run with assertions enabled. Okay, I'll explain. So, how do I run? Java. Fine, I would use -C per whatever options, but there's another option called -EA, enable assertions. Unless you have used -EA, your assert statements never get executed. They are never to be used like. So by default, assertions are not executed. You need to enable assertions while running the code for the assert to be evaluated. Otherwise, asserts are not evaluated. These are assertions, okay? So assertions never evaluated unless you enable them. Okay. So the idea would be to have test cases with your code itself. Fine. As you are writing your code, you can put your assertions there itself. Okay. So during the development, fine, while you are doing the development part, okay, you can always, because you keep on making changes, or even when someone is fixing, right? Okay, I fix something, but I'll then run it with assertions enabled. Okay, but what is the use of assert then? The idea is, what will happen? What do you think happens if this doesn't turn out to be true? With assert we always keep statements which have to be true. What if it evaluates to false? If okay, that would happen. I'm assuming we have assertions enabled. Then error. It's the assertion error. This would result in a assertion error.
If they are not enabled, then exception.
If they are not enabled, if you have not done anything, it's like there's no assert statement at all.
Comment.
It's like comment. And it's more like a comment then. Yes. Yeah. Fine. And another thing is, you could have assert, okay, your Boolean expression, and after Boolean expression you could use colon and have an expression after this also. One expression. That expression could be any type. Okay. Fine. That expression could be any type. What would be done? It would be used in the constructor of assertion error. So normally we keep our message here. So this is used for defining what goes as a message in my assertion error. Fine. So when the assertion error is created, what message would it have? You have the get message method in throwable. So that gets initialized by what you give after colon. Okay. Fine. So assert a Boolean expression. Optionally, you can put colon and a message. You have to look at how the enable assertions is done. -EA is for enable assertions, but what we can also have here is, you can say, okay, for these classes, assertions are enabled only for these classes, this set of classes, not for all. So enable assertions for, and you could be giving basically, so this exact syntax I don't recollect, but yes, there is a syntax by which you can specify only those classes which are in this package, all the classes in that package, even that way, or a specific class, only assertions enabled only for that class. Or you could be saying disable assertions but enable them only for this, overall disabled, but fine, or enable assertions but disable for this package. And so the various combinations which are possible. Okay. And so assertion error is only with assert. It's not being used much because this came in 1.4. Assert was not a keyword in Java. It came in 1.4. So from Java 4 we have this assert as a keyword. And so, but later there were other unit testing frameworks which are much better to use rather than having your test cases in assert. Assert would basically be used for test cases. So for unit testing, there is a separate framework called JUnit. Okay, so there is a unit testing framework called JUnit, and that may be used rather than using the assert. And but you should know, yes, assert is also there. Fine. Okay, so this is about the exceptions. That's about the exceptions. So now, what do we do? Next thing is exercise. We have already done the exercise related to creating our exception class and using it. So it's now maybe in the main method you might try out the try catch finally things. And it's only about putting it in the main. Fine. Try catch finally checking the flow. Fine. See, in the account class there's no point putting a try catch. Okay, fine. We are not throwing for it to be caught there in the deposit itself. And you don't do a throw and catch there. Fine. This method deposit is supposed to fail, so it should fail. Fine. So don't handle. But yes, in the main, the one who is using deposit, the one who is using the account class, for them, they are the ones who should be using the try catch finally. Fine. Not in the account class. Don't use try catch finally there. Fine. Many times that you might have try catch for the purpose of. I'll show that. I think I did mention about it yesterday, but still let me put it again. Some cases where you might put try catch in a class which is supposed to be throwing exception, but still you put a try catch. And for example, we have the class called BIOS, okay, which has a method to return maybe a byte array. The method is read sector. Fine. Parameter is sector number, and it has a throws for CRC exception. Fine. This could be fine. I'm just showing. So throw CRC exception, and maybe it has its own mechanism how it's reading from the disk. Those sectors are read, and if the CRC don't match, I have to throw new CRC exception. Fine, maybe something like this. So you have this read sector in the class BIOS. Okay, so here there's no try catch. Fine, but the one who is going to use this class, the one who is going to use this class is going to be something like this. We have this class called OS. Okay, fine, and it is providing this method which again maybe returns a byte array. Fine, the method is read file. Huh? Achha. Okay, so we have the read file maybe, fine, which says it could have parameters, what is to be read, how much is to be read, everything, fine. But this one has a throws file read exception. So it has its own class, right? Fine. It has its own exception class which it throws. It is not saying throws CRC exception. It decides its own exception. Okay. Fine. Because this was decided not based on what I am going to write inside this, how I implement. Fine. I have to write the throws here independent of how I am going to implement this. It's a read file method, and therefore I want to keep such an exception. Fine. Okay. So in this somewhere you will say, okay, try to do a read sector. Fine. Somewhere you have found the sector number, calculate the sector number, and then try a read sector. Okay. And if this gives me an error, catch CRC exception. In that case, throw new file read exception. Fine. Where maybe your first parameter may be the CRC exception object itself. So CRC, maybe this is CE, so this is CE, comma, maybe the message, or whatever the order of the parameter, maybe some message and everything, and something like this. But the idea is that your catch block, you have a try catch. Fine. You can have a try catch in your other classes. They are throwing exception, but they are throwing a different exception. Fine. It can't be throwing the CRC exception, so it can't have a throws for CRC exception. It can have a throws for file read exception. Okay. So, but yes, some statements can result in error such that you can't be returning your values. Fine. Reading sector has failed. I can't be returning some data for read file. It is an error condition. I must throw. But I can't be throwing anything other than what I am supposed to be throwing. Okay. Fine. That's why we use a try catch. In the catch, we again have a throw. Fine. So you could be having such scenarios. So when you have to have your proper design. Okay. What are the classes? What methods each one has? For each method, think of the throws also. Throws are equally important. Okay. What throws they should have. That has to be thought out, not by thinking what is the code I am going to write inside that. It should not depend on the coding which I am going to put here.
ट्राई कैच की जगह ऐसा नहीं करते हम ट्राई कैच तो मेन में थ्रो डालना पड़ता नहीं वाला
क्या
ये वाला
CRC exception का क्या कर रहा हूँ मैं? What is CRC exception? If you don't put a catch for CRC exception, क्या होगा? Can you use read sector कर सकते हैं? Compile नहीं करेगा. It won't compile, ना? It's a checked exception, yeah. It's a checked exception. Suppose it was an unchecked exception. Suppose it was an unchecked exception. If CRC exception was unchecked, तो catch would be compulsory. होगा क्या? Run time पे क्या होगा? CRC exception would be thrown from here. You have not handled it. This would be throwing a CRC exception. उसको CRC exception मिलेगा. यूज करने वाले को. And do we want that to happen? Right. We are using a read sector. We should have a provision. ये fail होगा तो क्या करना है? We should have thought of it, ना?
कैच में थ्रो डाला तो बाद में
Catch my throw, because I am handling only for the purpose of throwing a different exception. I have not got the data from the sectors. I can't be returning data here. Read file can't be returning data. It's not possible for me to give and say, oh, this I have read it successfully and give something else.
So catch में throw डाला.
Catch में throw डाला.
खत्म हो जाएगा तो उसके बाद execution continue होगा.
नहीं, कैच कहाँ खत्म हो, कैच में से थ्रो हो गया तो थ्रो कर दिया ना. यू आर कमिंग आउट ऑफ द मेथड विद द थ्रो. कैच में अगर रिटर्न लिखा होता तो रिटर्न हो जाता. फाइनली तो है नहीं ना नीचे कुछ.
नहीं, दूसरे कुछ स्टेटमेंट का होगा.
हाँ,
तो वो नहीं.
कैच में भी थ्रो हो सकता था पर वो नहीं चेक किया केस. Fine. In catch also you might have a throw. Fine. Okay. तो क्या करें? प्रैक्टिस कर लें. ट्राई कैच और फाइनली को मेन में करना पड़ेगा. अकाउंट क्लास you won't change that part, right? At least not the don't put try catch there for the negative mount exception. You can have the things happening from the main. Okay, and if you want to create few levels of methods, you can have a few static methods in the same class. Test account class, you can add a static method there which in turn calls the deposit method, creates account and calls deposit or something like that, deposit or withdrawal. And main is calling that static method and static method calls the deposit. So just want to create a few more levels of invocation. Runtime stack पे अगर कुछ ज़्यादा देखना है तो you can do that, because we have M1 calling M2, so okay, we have main calling M1 and M1 calling deposit. Fine.